Today's daily LeetCode problem is 3074 Apple redistribution into boxes. You are given two integer arrays, an array called apple of size n and an array called capacity of size m. Each element in the apple array represents a pack of apples. The ith pack contains apple I apples. You are also given m boxes, where the ith box can hold up to capacity I apples. Your task is to redistribute all the apples from these packs into the boxes. There are two important rules to remember. First, apples from the same pack can be split across multiple boxes. Second, each box cannot exceed its given capacity. Your goal is to select the minimum number of boxes such that all apples can be placed successfully. Finally, you need to return the minimum number of boxes required to store all the apples. Now let us understand the problem using examples. Example 1. The apple array is 1, 3, and 2. That means the total number of apples is 6. The capacity array is 4, 3, 1, 5, and 2. Our goal is to choose the minimum number of boxes whose total capacity is at least 6. If we look at the box capacities, the largest ones are 5 and 4. If we select these two boxes, their combined capacity becomes 9, which is more than enough to store all 6 apples. Since apples from a single pack can be split across boxes, this redistribution is valid. So in this case, we only need 2 boxes, which is the minimum possible answer. Now let us move to example 2. The apple array is 5, 5, and 5, so the total number of apples is 15. The capacity array is 2, 4, 2, and 7. If we add all the box capacities together, we get exactly 15. This means even after using every available box, the total capacity just matches the total apples. There is no way to skip any box here, because removing even one box would make the total capacity insufficient. So in this case, we are forced to use all 4 boxes. That is why the answer for example 2 is 4. We are given 2 arrays, one representing packs of apples and another representing the capacities of available boxes. Each value in the apple array tells us how many apples are in a pack. Each value in the capacity array tells us how many apples a box can hold. Our goal is to find the minimum number of boxes needed to store all the apples. An important detail is that apples from a single pack can be split across multiple boxes. So instead of tracking individual packs, we only need to focus on the total number of apples. First, we calculate the total apples across all packs. Next, we sort the box capacities in descending order. This allows us to use the largest boxes first. Then, we keep selecting boxes one by one, adding their capacity to our total storage. As soon as the total capacity becomes greater than or equal to the total apples, we stop. The number of boxes selected at that point is our answer. This greedy approach works because choosing larger boxes first minimizes the number of boxes needed. And that is how we efficiently solve the apple redistribution into boxes problem. Here the solution explanation. This solution uses a greedy strategy to minimize the number of boxes needed. Step 1. Count total apples. We start by summing all the apples in every pack. This gives us the total number of apples that must be stored, regardless of how they are split. As is equals sum apple. Step 2. Sort box capacities. Next, we sort the capacity array in descending order. The idea is simple. Use the largest boxes first so we reach the required capacity using the fewest boxes. Sorted capacity, reverse true. Step 3. Greedily fill boxes. We iterate through the sorted capacities and subtract each box's capacity from the remaining apples. Each iteration represents selecting one more box, as is equals x. As soon as the remaining apple count becomes 0 or negative, it means we have enough total capacity. At that moment, we return the number of boxes used so far. If as is equals 0, return I plus 1. Step 4. Safety return. If all boxes are used and capacity is still insufficient, we return -1. Invalid inputs. This case will not occur. Alright, now that the logic is in place, let's run the code on the sample inputs. Perfect. The output matches exactly what we expected. Let's go ahead and hit submit. And there we go. All test cases passed successfully. That confirms our greedy approach works efficiently and correctly. If you found this explanation helpful, make sure to like the video, subscribe for more daily LeetCode solutions, and I'll see you in the next problem breakdown.